Okay, welcome to the NUPOC Video Study Guide number 14. Let's look at question 11 in the General Math section of Guide 1. So this question is just asking us, what is Bayes' theorem? And this is actually one of my favorite questions. This is really cool. I think Bayes' theorem is really neat. Essentially what it does is it allows us to get some more insight into the probability of something being true or not based on some a priori knowledge about that event and some trials, which is really neat. This is sort of just one of the ways to define it mathematically right here. But we're going to kind of, it's best to just do an example, and you'll see how it works. So imagine that we had 10 die or 10 dice, and we knew that one of them was loaded, but we didn't know which one, right? So say we had to choose a dice. We can pick one of them, and we have to guess whether it's loaded or not, and maybe we can roll it a couple times, right? And then we have to make a guess. We have to give our confidence whether it's loaded or not. So without Bayes' theorem, we can roll it as many times as we want, but really all we can say is, we have 10 dice, we know one is loaded. So at best we could say that the one that we picked, there's a 10% chance that it's loaded. So that's the best we can do, right? But with Bayes' theorem, what it allows us to do is we can make a couple trials. We can throw the die a couple times, and we can use the results of those trials to change this confidence that it's the loaded die. So at a minimum, we know it's 10%, right? But we may be able to increase that confidence based on our trials. So let's say we get a chance to roll the die twice, okay? And let's say that the loaded die always rolls let's say a 6. Okay? So we pick our die and we roll it a couple times, and we find, let's say we pick our die, and we find that it rolls a 6 twice. So we have two trials, we roll it twice, and we roll a 6 both times, right? So now, intuitively, we may say, oh, well, maybe it is the loaded die because it rolled 6 twice in a row. Maybe there's a good chance. But without Bayes, we don't really have a quantitative handle on that. How much more confident are we? And it could still be one of the, there's still a high chance it's one of the fair die. I mean, 9 out of 10 of the die are fair. So, just because it rolled 6 twice doesn't mean it's a loaded die. So let's use Bayes and figure out what's our new confidence based on these two trials where it rolled 6 both times. What our confidence is that this is the loaded die. Okay? So let's just calculate what each of these probabilities are, and then we'll get this. This is our probability. We're going to say the probability A that it's loaded, and given B that we rolled 6 twice. So A is that it's the loaded die, and B is that we rolled 6 twice, or I'm just going to write 6, 6. Alright? Okay, so we want to know the probability that it's loaded given we rolled 6 twice. That's the probability, that's our confidence. Right now, the most we can say is that's 10%. So let's calculate each of these. So the probability of A, the probability that it's loaded, we know is 1 in 10. Okay, that's our a priori knowledge. The probability B that we roll a 6 and a 6, given that it's loaded, right, is 1, because if it's the loaded die, it always rolls 6. By the way, I should have written probability loaded here instead of probability A, since A is loaded. Now let's look at the probability of what we just said, probability of A, probability of B given A. What about the probability of B given not A. So given that it's the fair die. So the probability that we roll a 6 and then another 6, given that it's fair, right? Well, that just equals, it's a 1 in 6 chance times a 1 in 6 chance. So it's just 1 over 36, right? And the probability that it's not A, or the probability that it's not loaded, is the probability that it is fair, a fair die. Well, that's 9 out of 10, right? So let's just plug these into this equation here and see what Bayes tells us for the probability that it's loaded given our trials that we got 6 and 6. So probability, I'll write it over here so we don't run out of space, that it's loaded given our 2 trials that we each rolled 6 on equals probability of A, which is 1/10, times the probability of B given A, or the probability that we get 6 and 6 given loaded, well that's just 1, over those same 2 terms, so 1/10 and 1, plus probability that we get a 6 and a 6, given that it's a fair die, well that's 1 over 36, times the probability that it's not loaded, the probability that it's a fair die, so that's 9 out of 10. Right? So this just equals 1/10, or 0.1, over, this is also 0.1, plus this is 9 out of 360, which is 0.025. So this is just 0.1 over 0.125, which is 0.8. So I'm just going to write it over here. So probability that it's loaded, given that we rolled a 6 and another 6, equals 0.8, or 80%. So before using Bayes, the best we could say is that we had a 10% chance. That's all we could really say. But now Bayes, we can take that a priori knowledge and then account for our trials, and now we can say, given that we rolled a 6 twice in a row, we're 80% confident that this is the loaded die. Something else to note, which is kind of interesting, is that Bayes, if you look at this term right here, right, in the denominator, the probability that it's loaded, given we rolled both 6s, can only